Have you ever tried to wrap your head around how electricity works? Someone probably told you, electric current is like water flowing through a pipe. In that exact moment, a miracle happened in your brain. You took the invisible movement of electrons and matched it with the familiar flow of water. We call this analogy. But analogy isn't just a literary device you learned in English class. According to cognitive scientists, analogy is ubiquitous. It is a central engine of human intelligence, creativity, and problem-solving. It's the same tool Kepler used to figure out planetary motion, and it's how children learn new concepts. Today, we are decoding this hidden superpower of the mind, the ability to see the same relations across totally different situations.
Let's start with a definition. Analogy isn't about two things merely looking alike. It is defined as a similarity where the same system of relations holds across different sets of elements. Cognitive scientists call this process structure mapping. Your brain places two different situations side by side. It ignores whether the objects are similar and focuses on the roles they play. There is a critical rule here called the systematicity principle. Our brains don't like random matches. We prefer to map systems of relations that are connected by higher-order constraints, like cause and effect. Saying, the sun is yellow and the nucleus is yellow, is useless to your brain. But saying, the sun attracts planets just as the nucleus attracts electrons, that creates a deep structural analogy. So what actually happens in our brains when we map these structures? Research shows that analogy provides three distinct benefits for learning. Schema abstraction. When you align two situations, the common structure pops out. This structure can then be stored as an abstract rule or schema for future use. Inference projection. This acts like a bridge. If you know how a base domain works, like water flow, you can project those rules onto a new target, like electricity, to make rapid predictions. Alignable differences. Surprisingly, comparison helps you see differences too. Differences that play the same role in the structure tend to pop out significantly more clearly.
Now we reach the most interesting and slightly frustrating part of the story. Analogy transfer. When you face a problem, you should be reminded of a similar problem you solved in the past, right? But laboratory experiments revealed a dismaying truth. People mostly fail to retrieve these useful past cases. Here's the catch. Our memory retrieval is usually triggered by surface similarities, what things look like, not structural similarities, how things work. Researchers proved this with a clever study using popular films like Jurassic Park. They gave participants a persuasion task analogous to a scenario in the movie. When the surface details were different, only 30% of people used the movie strategy. But when the surface details matched, that number jumped to 70%. The good news? As you become an expert in a field, you get better at retrieving memories based on deep structure rather than just surface details.
Is this ability unique to adult humans? First, let's look at children. Historically, psychologists like Piaget thought analogy developed late. He was wrong. Current research shows that even infants and toddlers can perform analogical abstraction. However, they often fail because they get distracted by object similarity rather than relationships. What about animals? Humans exceed other species in this, but our closest relatives, chimpanzees and bonobos, do show relational ability. In one study, great apes had to map spatial locations to find a hidden reward.
Gorillas and orangutans could only do it if there was a direct causal link, like a tube connecting the spots. But chimpanzees and bonobos, they succeeded with only visual links, showing true relational mapping. And finally, the new frontier, artificial intelligence. Can large language models do analogy? Some studies found that models like GPT-3 performed quite well on analogy batteries, suggesting an emergent ability. But skeptics argue they might just be recalling training data. In fact, when tested on problems not in their training data, these models performed substantially worse than humans. The jury is still out.
Analogy is far more than a figure of speech. It is the spark that allows scientists to make discoveries, the tool children use to learn language, and the very framework we use to understand a new domain. Next time you say, "It's just like," take a moment to appreciate it. Your brain is running one of the most complex pieces of software in evolutionary history. Do you have a favorite analogy that helped you understand a difficult concept? Share it in the comments below. Don't forget to like and subscribe for more cognitive science deep dives.